is problem number 5. Determine the equivalent resistance and the total current in the network. This type of numericals will be appearing in the competitive exams like the NEET and the IIT JEE and all. Okay. Look at the network. It is having a shape of a cube, and all these edges are having equal resistors and each of 1 ohm. So all resistors have a value of 1 ohm each. Okay, and the two vertices, namely A and C dash, are connected with the help of wire to a cell of EMF 10 volt. Okay, 10 volt is the EMF of the cell. We have to determine the total current in the network. How much current is sent by the battery, and what is the total or effective resistance of this cubical network. So I will take, let R be the resistance. Okay, let R be the effective resistance of this entire cubical network, and also the positive of the battery sends the conventional current, and I will take the current sent by the battery is 6I, or I can also assume this as 3I. Multiples of 3 if you take means such problems will be easy to solve. So what is the current sent by the battery is what? 6I ampere. And when this current reaches the junction A, how many branches are there for the current? There are 3 branches at this corner point A. So that the resistors are all having same values, therefore the current will divide equally. This is the idea of taking what? 6I. Even you can take I ampere also, no problem. But carefully you will have to tackle that problem. Suppose if I will take 6I ampere means through this branch 2I ampere, and through this branch also 2I ampere, and here also 2I ampere, it will divide. Suppose if you take I ampere means then what will be the current through each branch? I by 3 plus I by 3 plus I by 3. Then also you can solve, no problem at all. But 6I I have considered. Okay students, now you see that the current flowing from A to A dash, from A to A dash, the current flowing is what? 2I ampere. At this junction A dash, again you see that there are 2 paths. So that the current will divide here I ampere and here I ampere. Understand that? Like that. You go from A to D, the current is 2I ampere. At the junction D, there are 2 paths. So along these paths, the current will divide as I ampere and I ampere. Like that, you look at the junction, that is A to B, the current is 2I ampere. When 2I ampere will reach the junction B, again how many paths are there for the current? 2 paths. So that this current will divide as I ampere and I ampere. Understand? Okay. Now you see this current of I ampere. Okay. This is the current I ampere flowing here, and this I ampere is flowing towards the junction D dash. So A dash to D dash is I ampere, then D to D dash is also what? I ampere. So this I plus I will become what? 2I ampere. 2I ampere current is flowing from which point to which point? D dash to C dash. Similarly, you see that the current I ampere flowing from A dash to B dash is what? I ampere. Okay, and the current flowing from B to B dash is what? That is also I ampere. So these 2 I ampere will meet at the point B dash, and the current flowing towards this junction will be what? 2I. So already this current is what? 2I. Now the current between B dash and C dash is also 2I. Similarly, the current flowing in this branch also I plus I will become what? 2I ampere. So that the current is leaving the junction C dash. So that 2I plus 2I plus 2I will become what? 6I ampere. So this is the current what? 6I ampere, which is flowing towards the negative terminal of the battery. Are you all understanding? So the entire cubical network is symmetric, and also the resistors are having equal values, and the current 6 ampere at junction A, when it enters, it is equally dividing as 2I ampere in the 3 branches, and it once again divides as I ampere and I ampere through the different branches, and finally when it reaches the junction C, all the currents 2I ampere, 2I ampere and 2I ampere will meet, and if the net current will become what? 6I ampere. Okay, so very clearly you understand the circuit. Then the EMF is what? 10 volt. And the current sent by the cell is what? 6I ampere. And the effective resistance is what? R ohm. So from Ohm's law, I can write 10. Okay, 10 is equal to 6I into resistance R. This is equation 1. Because voltage or potential difference or EMF is equal to what? Current into resistance. So what is the current sent by the battery is what? 6I ampere. What is the effective resistance of this network is what? R ohm. So the product 6I into R must be equal to what? The EMF of the cell 10 volt. Understand? Now we are going to apply Kirchhoff's voltage law to find the current, the value of the current. Okay. So now apply Kirchhoff's second rule. Okay, to the loop. See, carefully you will have to analyze the loop. Which loop is convenient only we have to take. Don't get confused much. So the loop which I am saying, you start from A. Start from the point A. Look at the point A, all of you. A. After A, you go up to A dash. From A to A dash. What is the current flowing is 2I ampere. And what is the resistance is 1 ohm. Understand? So we are proceeding from the point A to A dash in the upward direction. And the current 2I ampere is also flowing in the same direction. So the IR product must be positive. Understand? So to the loop A, then A dash. Then from A dash you go up to B dash. Then from B dash you go up to C dash. Okay, C dash. And from this C dash you come through this wire up to the battery and follow up to the point A. So that the final point of the loop will be what? A. We started from A and we are returning back to A itself. So clearly you look at the circuit once again. We started from A to A dash. Current flowing through that direction is what? 2I ampere. 2I ampere into resistance is what? 1 ohm. So what is the IR product? IR product is what? 2I into 1. Okay? Like that. Now you see A dash to B dash, what is the current flowing is? I ampere only. I ampere. So you proceed from A dash to B dash. Current I also is flowing from A dash to B dash, means IR product must be positive. So I into 1. So plus I into 1. Then from what? B dash to C dash. Look at the point B dash. You proceed from B dash to C dash. See the direction. What is the current? Current flowing through this branch is what? 2I ampere. Again 2I ampere. So in the same direction only current is also proceeding. So IR product is once again what? Positive. So once again what? This is equal to 2I into 1. Okay. So the algebraic sum of the current and the resistance product we have taken. And the current 6I ampere is leaving the junction C dash. And it is again completing the circuit and it is coming up to the point what? A. The loop is getting completed. So now what is the algebraic sum of the EMF? There is one and only cell of EMF 10 volt. So this current 6I ampere, is leaving which terminal of the battery? Yes, it is the positive terminal. So what should be the sign of the EMF? It is also positive. Many times in many problems you have seen, is it not? So while completing the circuit, when the current is leaving from the positive terminal, then this 10 volt is positive. So this is equal to what? 10. So 2I plus 2I. So 5I is equal to 10. Therefore, what is I equal to? 10 by 5, that is equal to 2. Therefore, the current in the circuit I is equal to what? 2 ampere. Okay. So the current in the circuit is how much? It is equal to 2 ampere. So the second part we have found, the total current in the network we have found. And if you apply this value in the first equation, means we can find the value of what? Resistance also, is it not? So substituting the value of current. So substituting I equal to 2 ampere in equation 1. So 10, that is a 6I. 6I into R is equal to 10. So 6, this is I. Okay. So I value is 2. 6 into 2. okay, into R. This is equal to what? 10. So 12R. This is equal to 10. Therefore, R is equal to 10 by 12. This is equal to what? 5 by 6. So this is the effective resistance. So the equivalent resistance R is found to be what? 5 by 6 and its unit is ohm. But what is the second part? Total current only they have asked. Is it not? We have found only the value of I. What is the effective current or total current sent by the battery is asked. What is value? It is 6 times I. Is it not? So this is subdivision 1. So the effective resistance, the network is having an effective resistance of R ohm. That R value is found to be what? 5 by 6 ohm. And the current I is equal to 2 ampere. I means what? The current flowing through this branch. And the net current flowing in the entire circuit is what? 6I ampere. Therefore, so net current or the total current is given by 6I. That is equal to 6 times what? 2. So this is equal to 12 ampere. 12 ampere is the current flowing through the circuit. Have you all understood? So you have to draw the circuit and practice again and again. One shortcut I will tell you, my dear students. The starting point of junction is what? A. And here 2A, 2A, 2A. Current will divide 2A, 2A and 2A. Similarly, at the ending point junction is what? C dash. There also current will converge as what? 2I, 2I and 2I. Is it not? So at these two corner points, 2I, 2I and 2I, and here also 2I, 2I and 2I, you first write. Naturally, in all the other branches, the current will be I ampere only. Blindly you can practice like that. So draw the circuit, corner point A dash, current divides as 2I, 2I and 2I. Similarly, the opposite, diagonally opposite corner C dash, the current will converge as 2I, 2I and 2I. Remaining branches you can write I itself. Okay? I hope you must have understood. Okay, fine.